Yeah, hello everybody. We are now gathering for a new session with MotorSizer 4.0, and this is built on the platform 3.0. I'm Peter Nielsen. I'm normally representing JVL for support team and also for the sales team. And we also have Alexander in today. Maybe he can present himself.
Yes, hello, I'm Alexander, also from support and sales team. I work together with Peter. Peter will be doing the presentation and I will be helping with the questions. And if you ask any questions, please do. I will present them to Peter.
Yes, the agenda for today, we're talking about the new MotorSizer, which is built on the old platform 3.0. And as you can see, the pictures are the same, but except for that, it's looking a little different. And I passed through all the different things we have to consider and how we're using it, starting from here. But you can see we're talking about the mechanics as we did in the old days, also time and distance, what's the application for this, how do we sort the different things we want to look for, what kind of motors, and then last, the calculation and results. And we will look into the program at that time. But again, and like in the old one, we have the belt drive, different applications within this area, or lead screw or disc types. This is a web-based calculator. It's easy for you to use. There's a lot of motors in this where you can select from the JVL motors and also gears. I think there's about 3,000 different motors and about 400 or 500 different gears. And you only need to know a little about servo and stepper motors. In the old version, you had to know a lot about how to select the different motors and have to know about the different torque curves for the motors. In this new version, you can also save the projects. You can, of course, make a new one. You can save it and then get back to them later. I can see them from here in JVL, so we can together work on these different applications if you need any help for this. And here you can see the link for this. I'll come back to that a little later. But if we start with the mechanics, we have these three different types: belt-driven construction, lead screw construction, or rotary disc construction, like in the old one. But as you can see, the screen is looking a little different. You have to log in before you can do some calculations in here. And at the moment, it is possible to go to the PBNB, part number builder, and register for this. And then you use the same password as you did there. So when you have logged in, you have this area where you can see different things, calculate, compare things, the projects you have been working on. And again, here we have some things like belt mechanics, profile, timing, and all that, and the filters. To make it a little easier to see, for some of you who has a small screen, you can see here we can calculate things when we have keyed in belt information or the lead screw information, disc information, and also the motion profile. And when you press calculate, you have to select which project it is, which scenario it is, and then it'll be saved in this list you can see down here. Also, you can see here, for example, these projects we have here above the line, that's my own project. Some I made within JVL. But I also have some customers out in the world. So I can see one of the customers here and I can go in and see his projects. For those of you who are a distributor, this means that you can go in and see your customer's projects and help them with their settings and the application they have. Also here you can see JVL is in, and I can see some of my colleagues' projects and go into this list. If I open the list, I can see all my colleagues, and I can go in and see what's happening on the different projects. Here you can select what kind of application I'm working on, belt drive. press either right or left, and you select between those 3 different application types. You key in some mechanical information. How much do I want to move forward and backwards? You have the small drawing down here. You can see what the different things are. Do I want to go horizontal or vertically? And this go vertical. If there are some, sorry, this one is vertical. You have some friction maybe in the system. If you know it, you can key it in. You have some information about the pulley and something about the belt as well, efficiency. And last of all, you can key in some extra information about the precision in the mechanical system you have. Motion profile, as it was in the beginning or the old version, how long do we want to go? Do we have some pause between each move, like you can see here? How long is the time for the move you have? I have 1 second, for example, for this move. How much time do I need for the acceleration? You can key it in here. And also you can see the deceleration be the same for this calculation. And also, like we did in the past, you have to select 2 out of those 4 options we have here. So I can select either the total time and the acceleration time, but I can also select the total time plus the slope or the length I want to move while I'm accelerating. But you have to key in 2 of those, and the other one should be 0. Then we have this last one from the past also, when we are working with stepper motors in open loop. They sometimes need a start speed. For most applications today, where we have a closed loop system for the Mack motors or the MIS motors, this will always be 0. But you have the option to change and say, okay, for open loop systems, change this value. Then we have the filters over here. And here you also have some options. You can see motors, gears, IP protection, supply voltage, and performance. So let's take them from the top. The motors. You can go in and see, I want to look at stepper motors, the MIS motors. I can also look at the Mack motors, or you can remove this if you want to. So I say I'll concentrate on the MIS motors. You can click this one and it'll be empty. Then you can concentrate on this. For the MIS motors, you can say, okay, I want to look at incremental encoders. I want to look at absolute encoders. And also, sometimes you need a motor with double shaft. This option is available for some of the motors. In this case, it's not specified. That means you're looking for both motors with and without double shaft, rear shaft. And again, with Mack motors, also you can look at motors with incremental or absolute encoders. Connectivity, not specified. That means it looked at all motors. It could be that you're going for motors with EtherCAT. It could be motors running IS-485 or 232. Then you just select this from the list in here. Also STO, safe torque off is possible, and brake. But as default, it's set like this, because that's normally the cheapest solution. If you select absolute encoder, it's more expensive. Double shaft gives some extra expense. Connectivity depends on the application, of course, and that you have to decide. And also without STO and brake. We have more filters for gears, for example, and then here you can see the different types we are using. We have some planetary gears like the HTRG selected here. We have some low-cost planetary gears, different types, worm gears, and rotary tables. And you can also select if it should be an ankle type. In this case, it's not specified. That means it'll take both the ankle versions and the inline versions when it calculates solutions. IP protection. Here you select what you want. As a minimum, we say IP 42, 55. And for the gears, we take them all. If you want them all, just click. If you say, I don't want 65, but 66 and 67, just click it and it'll take care of it when you make the calculation and find solutions for you. More filters, supply voltage. It could be either AC voltage or DC voltage. And we have some different options, and you mark what you want. But as default, it's all options. Now we come to the calculation itself, and that's what we call the performance. When we start up, we have this button saying optimization, and that means if it's on, it'll make the optimization and find the best solution for you. And you can also see here it says minimum counts. That means it's looking for at least 5 solutions for you. You can say it should be only looking for 1, it could be look for 10, 25, or 500, or all. That's all up to you. You can also click this one and say, I don't want the optimization, but then I have to draw these at some point and say what power rated values should these motors go for, or max velocity. Then it's all up to you how the settings are. In this case, it'll find some solutions for you, if there are any in the application. We also have the advanced version. Here you can see we can go and look at power peak, 0 to 100%. Also torque peak, 0 to 100%. And that's where we start, because you want some solution. That means that we don't want to put in some obstacles so you don't get any solutions. So that's the reason for this. You can also look for precision, say it should be within 1 millimeter or something else. And then last year we have inertia ratio, which could be also nice for you to look into, because if you have some system with a lot of backlash, gears, other things, you should keep this value down and level. Otherwise, it'll not be stable system. And last, of course, there's a weight. It could be in some applications you want the motor and gear to be as small as possible. So you also have the option to say it should not weigh more than 15 kilos or 5 kilos or whatever. As you also can see, there is a lot of question marks around here. And it's telling you a little about what does this mean. One thing more I want to tell you is, of course, when we look into this one, you have 100% here, you have 50% here. And what does that mean? That means if I have made a calculation, a first calculation without motor and gear, it comes up and say to you, I need a motor for 400 watt. And it'll be looking for motors for 400 watt. But if this is put into 50%, then the use of the motor I'm looking for is only 50%. That means instead of looking for something for 400 watt, the motor here should looking for something that could run up to 800 watt. I'll come back to about the max velocity as well a little later. But if you look back on the applications you're making, you often want the motor to run as fast as possible and then put in some gear that can increase your torque in the application, or can lower the inertia in the system. But I'll show you a little later again here. You can see here, let's take a Mach 400 motor, you have the torque curve here, saying we have a continuous torque about 1.2 Newton meter, and the peak torque that goes up here in about 3.6 Newton meter. So if I say I want to run 100% speed, it's about 3000 RPM, which is the nominal speed of the motor, and 75% of the speed is around here. So I'm looking for some solution with this in this area. Okay. Now we also have the stepper motors. And if you look at the curves for those motors, you can see you have torque cone dropping down rapidly, depending on the voltage you're using. Lower voltage, dropping fast. Higher voltage, supply voltage for the driver, it's dropping a little more slow. So as you can see here, if I want to use something like 3 Newton meter, 3 Newton meter, I have the red area for the high voltage and have the blue area for the low voltage here. So that's where we have to look for solutions. In our system, we have saved all the torque curves for the motors, speed torque curves. So I'll go in and look at those curves and find the best solution for you. When we have made the first calculation, it comes up and show you how the profile is looking. You can see the acceleration coming here. You can see you need some higher torque at this while it's accelerating. You can also see the power, the red curve, how much does it need, and how much does it need when you're running constant speed and deceleration. And then you also have the pause afterward. So this is the total cycle of the motor. When you click at this text in the program, you can remove this line inside. So just click on the text and you'll see the red curve disappears. You can get it back clicking again and it'll be shown. Sometimes, of course, it could be difficult to look at these and see what does it really show. Is it behind this curve or is it behind some of the others? So this option you have. You can also see here, it shows you the entire circle. If I click once more, you can see you can also select only a part of the rest time. And that's, for example, if you have an application, you're running for about 1 second, and then you have 10 seconds of pause between each cycle. Then this part of the curve will be very small and you can't see all the details. So you can select, I only want to see a part of this rest time. You can also look at the acceleration only and the deceleration only. And again, here you can see that's just the acceleration shown here. So I take this part and I just make it bigger for you so you can see what's happening. And as I told you, click on this and the curve disappears. Now I made the calculation, and it sometimes takes a little time before the results come up. But you will see a little later when we have the actual built solution or application or any of the other ones. But you can see we have some results coming up, and we have 13 different results coming up. This one is the default. That's the default calculation before we see look for motors or look for gear combinations. Then we have some motors, Mach 400 D2 types, that 10 solutions. And we have 402, also D2 type, and we have 2 solutions. So you can click on these marks here and you can open them up and you can see what types do we have here. It could be Mach 402 with the gear 100 to 1, or it could be 402 10 to 1, or whatever. It'll be shown here. And the same, you can close it down again and you can open this and see all of those 10 different solutions. And you can also open this default value so you can see what supply voltage was this made for, what's the motor power rated, calculated, also some of the other things you can see here. There's a long list and you can scroll forward and backwards and up and down to see all these different values. You can also see here, there's a 0 in front here. Here it's in the back because it's an old version we used. But if you go in here and open this one up, you can mark one of the solutions and you'll see this one becomes 1. And you will also see one is coming up here. And when you have selected a few of those, you can press compare or print, and then you can see all the data and curves coming back a little later. And last, when you make the calculation, you also get some messages, which you could see in the beginning. And it was mainly used for maintaining the work. As when we try to make this program, we try to see what went wrong and where did the different solutions go when it was removed from the calculation list. And I can show you that a little later. It's not something you normally use, but it could be nice to have sometimes. Now you can see here, I have opened one of those and you can see the solutions. You can see what kind of motor is it, some description of it. You can also see the gear type. When you hold the cursor on top, you'll have all the name. But here you can see the description again, say it's a 16 to 1, 2-stage, 15 arc minutes, and so on, information. And you can see here also, it's running at 24 volt DC. So you can see with this, it's possible to run. What's the power rated value needed? 289 watts. And Mach 400 gives 402, gives you about 400 watts, so that should be big enough. Yes. With the compare, as you can see, you press the button and then you can see all the information you put in for the mechanics, where it's moving, friction, the pulley size, diameter, thickness, how many do you have, belt weight, the efficiency of this one. If there's some other rotating inertia, it's also written in here. And then we have the profile described here with the 800mm move, some pause between the moves, 1 second and 0.15 seconds for the acceleration and deceleration. And here you can also see it's calculated what's the slope for this one and what's the length for the acceleration. That's also nice to know for many applications, depending on what you're doing. But if we look underneath, we can see it shows default values. It does this twice because we have marked it down in the list. But we also marked a 402 and a 402 motor with a different solution. And you get some picture of the motor, and you get some picture of the gear, and you get all the details underneath. In the bottom of this compare list, you will also get this profile showing again what's torque, what's the velocity, and what's the power needed for the motor. So you can see exactly. And again, you can press these texts and it'll be removing these lines on the screen. There's a little more on the new ones, but I will again show you a little later. Now we got some information about how this program selects the different motors, and I'll show you a little more for Mac and MIS motors. Again, this was the start, saying we look for motors for 75 to 100% of speed. 3000 is 100% and 75%, that's about here. So for Mac motors, we are looking in this area. But as we were looking before, we can see the torque curvings going like this. You can also see the power output of the shaft is looking like this. So we were wondering, is it a good idea to find the highest speed for these motors? And normally it's not a good idea because we are running at a very low torque, and that's not the best performance in. So if you try to multiply these two curves with each other, you get a curve like the green one here. And that's the efficiency of the motor, you see. So the motor is most efficient if you're about this area. So that's what we're looking for all the different motors, to find this point. So we can say that's where we are starting looking for solutions. And this we normally call PXT, P multiplied by T max for this motor. Now we also have this point. This is also nice to know, because where does it end? Which speed is the maximum for this voltage we are using? And if you want to say, okay, I'm looking at 75% of the velocity for this motor, it'll be this area. So you get an area from there and saying plus 25%, that means we take 25% of this distance we have here. So we're now looking for solutions in this area. That's where the motor is most efficient and gives us the best result for this application. Of course, you can move these limits to what you want, but this 75 is looking down and this one is moving it up a bit more. So if I write 120 here, oh, sorry, this is distance. We go back to this. If I write 120, it's going a little further out here and say, okay, the 75% is still this distance, but I want to look a little higher in speed. Then I can just select another speed in here. Now we go to the real thing here. And if I'm lucky, I get the right screen coming up here. Now you can see this is how the MotorSizer is looking when it starts up. And I started up making some different scenarios, and one of these we can see here. Here we have 500 as a load mass. We have 90 degrees moving. It's going up all the time. There's no friction in the system, information about the pulley and all that. information about how should it go, how long, within which time. And again, here I've just selected the standard ones. I should have at least. If I select 50% here and 75 to 100%, 5 different versions. I want at least 5 different solutions for this one. And I haven't touched these at this point. I press calculate, it comes up and say, okay, this is what you have selected already here. You can see calculate, and it starts calculating. And now you can see up here, it says I'm calculating. Now it got some results for you. Default information, also Mac 400, Mac 402. I can go here and say, I can want to look at all these different solutions. I can click at the first one, for example, close this one down. I can open this one. I can select this one. Now you can see I've selected one of each. I have at least 4 plus 12 solutions. So there's a lot to choose between. Now you can see it comes up and I can say compare to this one. And I get the screen you saw before, information about the mechanics, information about distance and timing, speed. And we can go down here and you can see what solutions do I have. The name, the default motor, that means it's not a motor, it's just before we put in motor and gearbox. And then here you can see the gear, and you should also normally be able to see the motor. I don't know. I think you get you can see here, when I click this one, I get a data sheet sent to my email. That's also very useful. You can also see it here. I can get data sheet for the gearbox if you want that. I can go down, I can look at different things. For example, if you look at, let's see here, we have calculated the rated power for the motor. It is 188 watt. The motor can give you this. That means it's loaded 52%. So you get this kind of information looking down in the list here. If we go down to the bottom, now we have again the motion charts. And if we take one of the motors, the first one is for the default, that meaning without gear and motor. But if we go to the first motor, you can see here, get some information about what's the torque, what's the power, what's the velocity, while we're accelerating and while we're running constant, decelerating, and then pause between. And again, you can remove the lines we had before. If you go down further, you have here the first motor. And here you have the normal torque charts, torque versus speed. You have the speed out here. And you can see now the continuous torque the motor can produce, and the peak torque is like this. And the blue line is telling you what does it need while accelerating, and the red one while it's decelerating. So you can see we are fine below the limit we have here for rated torque. Without any problems, this motor can run. 402 is looking more or less the same. So you can go in and see these curves, and that's quite useful. I'll show you a little later with another application. I go out again, print, just give the print of what you just saw on the compare screen. Then we have the user guide, and here all the different things are described. So you can go in and see what the different things means and what options you have around here. Also very useful. Okay, we talked about messages, and here you can go in and see what's happening inside here. It's a very long list. I don't want to go into details, but as you can see here, it says, first of all, default calculation, maximum velocity, peak power, power rated, torque peak, torque rated, and so on. So that's what it's calculated before it's looking for motors and all that. Then we have made a long list where you can check up the gears, and some problems with some of the data in this, it's removing these data. So you don't get any gears that don't make it right dimensioning for you. So you can see here now it's looking for 3,000 different MIS motors, 499 different Mac motors, and a lot of gears as well, 483 different ones. And then starting calculating, in this case, it's looking for motors and from power rated reduction. So it's looking in what areas should this run. and you get a long list of all the things once they can be used for the application. Then it's looking for IP protection. What limitations have we made in the filters? And we can continue like this. If we go to the bottom, you can see all in all what's coming out of this. And you can see there are 75 different ones coming up. And out of this, we only have 17 that's going through all the way, and that's the result you see later on. I go back here. I try to make a new calculation. Also here, you can see this one has changed, but I'll go back and tell you why it's doing like this a little later. Now we're looking again, and you can see the load is different, but we're making new calculations. And if we're lucky, we get some good motors we can use. I think this one would good. I want to look at this motor, and then I want to make a compare. And if I go to the bottom of this, now that's also fine. Someone has made a filter for me, I think, inside here. And that's often changed by somebody. These motors are selected, that's okay. We're looking for these different gears, okay. Hybrid protection is also okay. Supply voltage, no, it's dropping up. Performance. So, advanced. There are no limitations here, it's just taking maximum for all those, so that should be okay. We try and make a new calculation, see what's happening. No, I only get this motor. I guess it's because when I made this, it was made on my PC back, so. This is also nice when it happens. Give me 2 seconds. We got out of this. I think we should take the last one. Now you can see when you're calculating here, and you start at some point, saying I'm starting at 50%, I'm starting at 75%, and you make the calculations down here. You can see after a time, and the calculation is finished, this has changed sometimes. It's because it's not finding any solutions within the ratios. So it's taking it down in steps of 5 until it finds enough solutions. So if you ask for 5, it's dropping down until it has at least 5 solutions for you. So this is made by itself. It's changing this down to the minimum, and then starting also to decrease this one until it's becoming in this area. If I now try to go back, I could either do one thing or the other. I can say I want to look at all solutions, or I can disconnect this one and make a new calculations. Then you'll see that you get a lot of different solutions, and in this case 279 different ones. So there's a lot of solutions for this applications, depending on what you're looking for. Maybe that's too much for most of you, and I agree, it could be a lot of work to find out, but maybe you also have a motor at your desk saying, I have a Mac 1500D something, is it possible to use this one? And in case you can see this, yes, I can go in and look here again. If I have this type of gear, I have this type of gear, you can do it. There's no problem in that. So I can select this solution, I can select this solution, I can make it compare again. And I can go down here and look at the curves and see how it's moving, what does it need. And last here you can see how does it look when you have a motor like this. Very interesting, because this is continuous torque we are here, and when we accelerate, it goes up like this, so you're using more than 100% torque in the motor. When you decelerate, you use less, that's correct. But because we are running only a little time, then we have a long pause, it's okay to run at 100, I don't know, 150 or 200% torque for a shorter time. Normally we say we can run 200% for about 10 seconds. We can run about 300% for about 3 seconds. But I tried some time ago to make a test with the Mac 400 motors. I ran it from 20% load up to 100%, and then I tried to cool it off and to see how long it take for the motor to cool off to 20% load again. And it took about 70 seconds. And that means if you want to use an application with 300% torque, then you need some big pauses in between each move. And that's very important to know, that it takes some time to cool off from a motor when you are running a very high torque. If we go back here, we could also select another motor, of course, Mac 800, for example. Then the gear ratio is probably different. And we can go down and look again. How does it react on this one? And okay, we have selected already the other ones, but if we have Mac 800, it's coming down here. You can see it's also overloaded for some time. But you have the curves, and you can decide, is it good enough? How much pause do I need before I can run the motor again? The calculation is only made within within the total time we have put into the system, the rest time plus the total time of movement. So you say I make it 300% torque, next time I run again, the motor will get overheated during time and you'll have some problems.
Peter?
Yeah?
May I jump in with a question?
That's okay.
Yes. That's a question here from Scott, asking about if MotorSizer will let you know the recommended load factor to be used in Mac torque.
No, it's not. And it could be, if we go down, I think I can show you maybe. If I go down here, there's some information here. That was what I was talking about. There's some information about this. And you can see here for very stiff systems and no backlash and very dynamic systems, you can go between 0 and 25%. 25% is not what should be written. It was because we were talking about percentage before, but now it says ratio should be 25. So there's a writing error here. So it can be rather high, this load factor. If we have some medium system or you have some system with backlash, you should go close to 1 to load ratio should be quite close to 1. So it doesn't tell exactly, but you can see what the limit is for those applications here.
Sorry?
Yeah, it's difficult to tell exactly for the system you're talking about, because I don't know about elasticity in the belt, for example. I don't know about how much backlash do you have in the gear. That kind of information should be added. Then we can maybe find out what is possible or what's recommended to use at least. But that's some information. If you have a stiff system where the wheel is mounted, it could be a disc drive where it's mounted directly on the motor shaft, it will be very stiff. For example, for our chocolate machine, for those of you who have seen that, we have 2 wheels turning around where the chocolate is moved from one side to the other. And if you look at the disc of those, the inertia ratio is about 170 to 1. But there's no gear between, and it's a very stiff system. If we have put in some belt drive with a very elasticity in the belt, it would not have been possible. Then we should have maybe 3 to 1 or something like that. So it's very much depending on the system, yeah.
What if I find a solution in MotorSizer? Can I see the load factor that I have to key in Mac torque, the inertia ratio?
That was something I didn't show you. And you can see here we have some information about duty cycle and all that. This screen is not very big. You can see I can scroll it up here all the way to the other side. And up here you can see different things we can show you. If I go up here, I have a list of different things I can select to show you. I can remove them, I can add them if I want to do this. And if you go down the list here, you can see inertia ratio. You have the inertia of the load, you have the inertia of the motor. So that will be shown, and you can also have the inertia ratio here. So that will be somewhere in here on the list. So you can go down and go forward and backwards. I think I have to use the keys instead. That's much better. Yeah. Here you have it. You can see for this motor, for example, it says the ratio is 7.88. And that should show you exactly what you have. If you want it to be as small as possible, you have another option, because you can say, I want it to be ungrouped. And that means you can see it's removing the information that is a Mac 1500 or 800, but you get all the results anyway. And then you can click here and you can see it's sorted in different ways. You have a 8.79 or as maximum, and then you have a very low one here because you have a bigger gearbox probably with a bigger ratio. So that way you can also decide what should the inertia ratio between load and motor be. So if you know you have a system with backlash, I would go for this one rather than going for something like this one. So you have the option here to tell you something about the system. And in combination with what we saw before, when we're looking here, then you can decide what's the best solution for me. Another thing I could show you, this one will just set the default columns up coming here. And then you can decide from this one. And you can group it again, just clicking back here. Now you can see they're grouped, all of them, so it's easier to see. And we are just working on the possibility to move these different things forward. It's already changed. I talked to the guy that's making the program for us. We can exchange those columns in the way we want to do it. So if I think it's important to know the inertia ratio, I can move it up forward, and I would only have to scroll a little up and down to find the right solution for us. So you can see I can just put it in another place. You also have some other options. You can make filters on the gear numbers, for example. Say I'm looking for gears with ratio, let's say 16:1. I don't know if there's any. There's none. 16, there is at least somewhere. But that's just a number. So if I'm looking here, it could be 16 somewhere in the list here. In this case, it is a ratio, but it could be something else. I can also look for different gears. I say, I only want to look for these types of gears. And you get these options. So you can sort all of the different things you see here. Both with text, you also have options, contains, does not contain, starts with, and all that kind of thing. So that could be quite useful sometimes. And especially this with how much, maybe not, see if we have some good ones here. Newton meter, calculated value, what's the calculated value? Maybe what's minimum, maximum here, should be like this. Goes between percentage. If you take this motor, it's used almost 80%. If I select Mac 4500, about 30%. So this gives you an idea how much load does this motor have when it's running this application.
Before we finish, I would like to remember that you can ask questions. Please write in the questions section if you have any. If we do not get to reply to them during this webinar, we will reply to you on email later.
Do you have any questions? Sometimes you need to try to use it a bit, and then you will find out. And then just write to support, and support will help you with the solutions. As you can see, we could all go in and look at the different applications we're working on. We can also make it here, the application, and then we can load it to you instead. So it's in your box so you can see it. So just ask us and we'll come back to you.
I have a question here, if whether the results are linked to the PBNB.
Nope, it's not. The only way is, no, not the results. The only thing you can get from the PBNB is the datasheet.
I have another here for an HLMT rotary table disc gearbox. Can disc format be used, or are there other considerations?
Disc format. I don't know exactly what that means.
I think it's when you go do the calculation for a rotary table. Will you use the disc when you go to the motorsizer to choose the application?
Yeah, the disc. What we're looking for when we're using this gear, that's mainly the inertia of this gear. So the gear inertia will be put into the system. If you want to add this extra inertia, you can do that. I'm not sure you can do it at the outside of the gear. I can check maybe.
But the application to choose in motorsizer would be rotary disc for a
Yes.
turntable
Yes.
calculation.
Yeah.
Also, can the results be downloaded? For example, a PDF to send to a customer.
You can print it, so you can download it that way. Use a PDF creator or something like that. That's possible.
So this is something you would normally do from the page in motorsizer called what's it called? It was compare.
Yeah.
Maybe you can show.
You can, if you want to print this result, you get it like this, and then you can, either print it or you can save it as a PDF.
Perfect.
Yeah. Yes, it's useful to also to send to the customer if they have something. But otherwise, you can just have the customer using it directly. That's also a possibility. As if you are the distributor, then your customers will also be visible for you as a distributor. So that's also nice sometimes to put it in his box, and then he can just pick it himself when he has the use for it.
Very well. I don't think we have any more questions right now. Oh, that was one. Just hold on. There's a question here from David, how to create an account for motorsizer.
Yes, the account as it is today, you have to go to the PPNB. And in the PPNB, when you've not used it before, there's a screen coming up where you can see exactly what to do. So you key in your name, your email address, and then you get in. You also key in your password, and you get the possibility to use that also in the motorsizer. It's the same. I hope we also can put it into motorsizer, but that's something we're discussing right now. Otherwise, just send a mail to support and we'll help you.
Yes. And the link for PPNB will be on the links section in our webpage.
Yes.
JVL.dk.
Yeah.
The link for motorsizer will also be updated right now. If you go to the links section in JVL.dk, it will be guiding you to the old motorsizer, but in a short while, it will be updated to the new one. It is just being officially released. I think that was it for the questions for now, Peter.
Yes, that's good. But if you have any more questions, just write to support@jvl.dk and we'll try to help you as much as we can. But thank you for participating, and I hope you can use this tool. If you have any questions, ask. We'll be ready for that. Okay.
Thank you. See you.
Yeah. Have a nice day. Bye-bye.